Alright, so I'm going to go ahead and go through the study guide for Unit 4. If there are specific problems that you need help with, make sure you know to fast forward through this video so you're not having to sit here and listen to me explain every single one, unless obviously you need me to. So this first one, I have to perform the indicated operations without using a calculator. So I notice I'm adding the two polynomials together because of this plus sign here. So all I'm going to do is I'm just going to combine like terms. So I'm going to find 4x cubed is my highest degree. So 4x cubed and 11x cubed make 15x cubed. And then I'm going to cross it out because I used it. And now my next highest degree is x squared. So negative 5x squared and 4x squared make negative x squared. And then I'm going to cross it out because I used it. My next highest degree is 1, so 3x. Can't combine it with anything else, so it's 3x. And then I have negative 6 and 9 as my constants, which make plus 3. I can't do anything else because they all have different degrees, so I'm finished. If I go over here and I look at this one, I notice I'm subtracting them. So when I'm subtracting them, I have to distribute this negative to everybody. So all my signs are going to change. So that's going to become negative, that's going to become negative, and that's going to become negative. And then I do the exact same thing that I did on number 1. So my highest degree is 3, so 4x cubed and negative 11x cubed make negative 7x cubed. And then I have negative 5x squared and negative 4x squared, which make negative 9x squared. And then I have 3x, can't combine it with anybody else. And then I have negative 6 and negative 9, which makes negative 15. If I look at number 3, I have to expand this, so I can just scribble this out and rewrite it again. And now I have to double distribute. So I have 9x squared minus 12x minus 12x plus 16. So now I'm going to clean up 9x squared minus 24x plus 16. So now if I look at number 5, 5x plus 2 all raised to the third power. So you have a couple of choices. You can either sit here and cross this out and write 5x plus 2 times 5x plus 2 times 5x plus 2, or you can use the Pascal's triangle to expand it. So I'm going to do that. So up here, I'm just going to go ahead and draw Pascal's triangle. So it always goes 1, 1, 1, and then I just add them up. 1, 3, 3, 1, 1, 4, 6, 4, 1, I'll do one more, 1, 5, 10, 10, 5, 1. So degree of 0, degree of 1, degree of 2, degree of 3. So I'm looking at this row here. So before I do that, I'm just going to decrease with the power of 3 for 5x. So it's going to be 5 cubed x cubed, and then it's going to be 5 squared x squared, and then it's going to be 5x, and then it's going to be no 5x, no 5 or x. So now I'm going to take 2, and going from, I'm going to increase it. So when I increase it, I have 2 cubed starts here, and then I have 2 squared, and then I have 2, and then I have no 2. So now, because this sign is plus, I know everything is positive. And now, because I'm looking at this row of my Pascal's triangle, I fill it in. 1, 3, 3, 1. So now I just got to clean all this fun stuff up. 5 cubed is 125, x cubed, plus 5 squared is 25, 25 times 2 is 50, 50 times 3 is 150, x squared. 3 times 5 is 15, 15 and 2 squared is 4, so 15 and 4 make 60. And then I have 2 cubed, which is 8. And I'm done. Can I erase this so I have some space for number 5? Alright, let's check it out. Number 5, again, raise it to the 5th power, I'm going to use Pascal's triangle. So 0, 1, 2, 3, 4, 5 is this last row, and I hid that one out there. So again, take my first term, start highest, go lowest. You always have, so notice I have exponent of 5, I always have one more term. 1, 2, 3, 4, 5, 6. I always have 6 terms. It's always one more than the exponent given. So if I have 7, this is a 7th power, I'd have 8 terms. So I'd have 8 blanks. So okay, so now I'm going to take 5, and I'm going to do 5 to the 5th, 5 to the 4th, 5 to the 3rd, 5 squared, 5. So now every time, since this is negative, every time there's an odd exponent, it's going to get a negative. If it has an even exponent, it's going to get a positive. So if I look at this first 5, it has a negative, an odd exponent, so it gets a negative. 5 squared has an even exponent, so it gets a positive. 5 cubed has an odd exponent, so it gets a negative. 5 to the 4th has an even, so it gets a positive, and 5 to the 5th has an odd, so it gets a negative. So now all I'm going to do is add in Pascal's triangle row. 1, 5, 10, 10, 5, 1. Now clean all this fun stuff up. 1 x to the 5th is just x to the 5th. 5 times 5 is 25, so negative 25x to the 4th. 5 squared is 25. 25 times 10 is 250. X cubed. 5 cubed is 125. 125 times 10 is 1,250 x squared. 5 to the 4th times 5 is 3,125 x minus 5 to the 5th is 3,125. And I'm finished. So now I'm going to erase all this because I don't have enough space. Probably should have zoomed in a little more, but again, you can rewind it if I move too fast. So if I look at this next one, I'm going to double distribute these two together first. So I have 2x squared plus 4x minus 6x minus 12. So I have 2x squared minus 2x minus 12. Personally, ladies and gentlemen, I always skip this step, and I'll show you how I do it. So just for future reference if you need. So if I look at this, I know my first two terms make that, and I know my last two terms make that. So to get my middle term, all I do is I do the double rainbow in my head. X times 4 is 4x. Negative 3 and 2 make negative 6x, and I add them up in my head. So negative 6x and positive 4x would make negative 2x, which is how I do that in my head. Just for future reference, do you have to do it like that? No, you can do it any way you'd like. So I have that. So now I have to multiply that by what's remaining. 3x minus 5. So I have 6x cubed minus 10x squared minus 6x squared. Actually, I'm going to go ahead and stack it. So that's negative 6x squared, and that's positive 10x, and this is negative 36x, and this is positive 60. So I have 6x cubed minus 16x squared minus 26x plus 60, which it looks like there was a typo on my answer key, or I should say righto. So go ahead and flip your paper. This next section tells me to factor the polynomial expression. So again, not using a calculator. So if I look at this first one, how am I going to factor it? Well, I have to use SOPs because it's an x cubed. So a SOPs, I'm going to take the cube root of each of these. The cube root of x cubed is x. The cube root of 64 is 4. So now I'm going to perform SOPs. S stands for squared, so square my first term, so x squared. The O is the opposite of that sign, so plus. This P is the product of x times 4, so that's 4x. This P is positive, and the S is I'm squaring the last term, which is 16. Before you finish, you always want to make sure that you cannot factor that expression, which you cannot, so I'm finished. If I look at the next one, x to the 6th, I get x to the 6th by doing x cubed and x cubed. So x cubed, x cubed. Factors of 8 that make -9, I get -1 and -8. I'm not finished because I still have a degree higher than 1. Usually that's how you know you're not usually finished. So notice I can perform SOPs on this. So if I perform SOPs, I get x minus 1. Now do SOPs. X squared plus x plus 1. I did SOPs, which is squared this, x squared, the opposite of this, which is plus, the product of this, so x times 1 is x, p is positive, and then it's square 1, so 1 squared is 1. I can also perform SOPs on that. So I get x minus 2, and then it's going to be square x, x squared, opposite of negative, positive. Product of x and 2 is 2x. The p is positive, and square your last term, so 2 squared is 4. And now I'm going to check to make sure I can't factor my degree of 2 expressions. So factors of 1 that make 1, can't do it. Factors of positive 4 that make positive 2, no, it doesn't work. So this is my answer. If I look at the next one, I have a GCF, so I'm going to first take out a 2x. So I'm left with 2x cubed minus 6x squared plus x minus 3. So now I'm going to factor this by grouping. So I have an x squared in common, and I'm left with 2x, oh, nope, I lied. I have a 2x squared in common. So I'm left with x minus 3. Over here I have a GCF of 1, so x minus 3. So my answer is 2x squared plus 1 times x minus 3, and you don't want to forget your GCF in your answer. Last but not least, number 10. X to the 4th is made by x squared and x squared. Factors of -5 that make 4, positive 5 and -1. I notice this is a difference of squares, so I can factor x plus 1, x minus 1. And over here I can say x squared plus 5. I can't do it. I know it's a difference of squares because that's not minus, so I'm finished. Alright, let's go ahead and do this next one, number 11. Divide each of the polynomials using long division. Alright, so I have 3x cubed minus 5x squared minus 4x plus 7 divided by, oops, that's a square root sign, divided by x squared minus 2x minus 4. So first question I have to ask myself is, okay, x squared times what is going to get me 3x cubed? Well, 3x. So now I'm going to go ahead and I'm going to multiply. So 3x times x squared is 3x cubed. 3x times negative 2x is negative 6x squared. And 3x times negative 4 is negative 12x. So now I'm going to subtract, so I'm going to change all my signs. and I'm going to add these two together. So these cross out. I'm left with x squared plus 8x, and bring down plus 7. So now do the exact same thing again. How many times is x squared going to x squared? 1, so plus 1. So now I'm going to multiply 1 to everything. X squared minus 2x minus 4. So now I'm going to change all my signs. So now I'm left with 10x plus 11. I can't divide anymore, which means that's my remainder. So my answer is 3x plus 1 plus the remainder all over what I divided by, x squared minus 2x minus 4. And I'm finished. So now I want to divide each of the following by synthetic division. So to do this by synthetic division, I'm going to take the opposite of this, so positive 3. And now I'm going to write down all of the coefficients from highest degree to lowest degree. So my highest degree is 3, so my leading coefficient is 3. My degree of 2 has a coefficient of 0, so I have to give it a 0. My degree of 1 also has a coefficient of 0. My degree of 0 is 2. This number gets brought down. Now I multiply. 3 times negative 3 is negative 9. Now I add. 0 plus negative 9 is negative 9. Now I multiply 3 times negative 9 is negative 27. Now I add, I get negative 27. Now 3 times negative 27 is negative 54. Add, I get negative 52. This last number is always my remainder. Because this started out as a degree of 3, this starts out as 1 degree less. So it's going to be negative 3x squared minus 9x minus 27 minus 52 over what I divided by, x minus 3. And I'm done. I could have done this with long division if I needed to, but the direction said synthetic division. So let's go ahead and move on to number 13. Number 13, find all the solutions to the following. Okay, so I have all these x's I'm going to have to factor, and I'm going to factor by grouping. So x squared is in common. I'm left with x plus 4. Take out a negative 6, x plus 4. So now I have x squared minus 6 times x plus 4 equals 0. So x equals negative 4. That's one solution. Over here, I have x squared minus 6 equals 0. So x squared equals 6. So x equals plus or minus rad 6. Make sure you can't simplify that radical. I can't, so I'm finished. Come over and I look at number 14. Number 14, I gotta first make this equal 0. So subtract 54x on both sides. I have 16x to the 4th minus 54x equals 0. So I'm going to take out a 2x. So I'm left with 8x cubed. Let me write that a little prettier. Minus 27. So here I know x equals 0, so I'm going to go ahead and write that just so my brain doesn't forget it. So now I don't have to worry about it anymore. I can just go ahead and worry about that. So I have an x cubed. It's 2 terms. I got to do SOPs. So I have 2x minus 3, cube root both of those. Now perform SOP. Square your first term. I have 4x squared. The opposite, plus. The product of your two terms, 2x and 3 makes 6x. The p is plus, and the s is square my last term, which is 9. So here, x equals 3 over 2. So now I got to look over here, and I got to try to factor this. So 2x and 2x, 9 is 3 and 3. So 6 and 6, that's not going to get me 6. What if I did 9 and 1? I have 18 and 2, that's not going to get me 6. What if I did 1 and 9? It's going to be the exact same thing as the other one. So what if it is 4x and x? 3 and 3. 12 and 3, that's not going to get me 6. 1 and 9, that's going to get me not 6. Doesn't work. So, quadratic formula. negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to go ahead and make that 8. 4 times 4 is 16. 16 times 9, 144. 36 minus 144 is negative 108. So I know it's going to become an I. 108 is 36 and 3. So square root. I have negative 6 plus or minus 6i rad 3 all over 3. So I can clean this up. I get 2 over 1, 2 over 1. So my other answer is negative 2 plus or minus 2i rad 3. And I'm finished. I come over and I look at number 15. I'm going to go ahead and I'm going to distribute first. So I'll just write my left side. Plus 4. So now I'm going to go ahead and I'm going to make everything equal 0. So since my biggest degree is on the right side, I'm going to subtract 4x squared and subtract 12x. So I have 12x cubed minus 4x squared minus 12x plus 4 equals 0. So I am first going to take out a GCF of 4. So I'm left with 3x cubed minus x squared minus 3x plus 1. So now I can factor by grouping. Take out an x squared, I'm left with 3x minus 1. Take out a negative 1, I'm left with 3x minus 1. So I have 4 times x squared minus 1 times 3x minus 1. So that's a difference of squares. I can factor it further. So all my solutions are plus or minus 1 and 1/3. Let's keep going. 16. Find the zeros of each polynomial function. So I can't factor this because there's no way I can get x cubed to make an x. So I have to use the rational root theorem. So I got to do p over q. So p is 6, q is 1, so this will be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. If I add up all of my coefficients, my coefficient here is 1. 1 and negative 7 make negative 6. Negative 6 and 6 make 0. So remember when I said all your coefficients are added up to equal 0? One of your roots is 1. So let's try 1. 1, my degree of 2 is 0, negative 7, and 6. Bring down the 1, I get 1, add it, I get 1, multiply, I get 1, multiply, I get, add, I get negative 6. Negative 6 times 1 is negative 6, and now I'm left with 0. So sure enough, that works. So now notice I'm left with x squared plus x minus 6, which means now I can factor it. Factors of 6 that make 1, positive 3, negative 2. So x equals negative 3, positive 2, and don't forget the one you used, 1. All right, let's look at number 17. So, got to do p over q. So 3 over 1, so I have plus or minus 1 and plus or minus 3. So if I add up all my coefficients, 1 plus 2 is 3, 3 and negative 10 make negative 7, negative 7 and negative 14 make negative 21. There's no way it's going to get 0. So I know 1's not an option. So let's try negative 1. 1, 2, negative 10, negative 14, negative 3. Bring down the 1. 1 times negative 1 is negative 1. Add them up, I get 1. 1 times negative 1 is negative 1. Add them up, I get negative 11. Negative 1 times negative 11 is 11. Add them up, I get negative 3. Negative 1 times negative 3 is 3. Add them up, I get 0. So now this has an x cubed expression, which means x cubed, I'm still not going to be able to factor it, so now I'm going to try either 3 or negative 3. Which one do you want to try? Let's try 3. 1. 3 times 1 is 3. Add them up, I get 4. 3 times 4 is 12. Add them up, I get 1. 3 times 1 is 3. Add them up, I sure enough get 0. So now I'm left with x squared plus 4x plus 1. I can't factor that. Quadratic formula, which means those answers probably are imaginary, but let's just test it. Negative 4 plus or minus the square root of 16 minus 4 times a times c all over 2 times a, which is 2. Now I have negative 4 plus or minus 16 minus 4 is 12 all over 2. And notice, it's not imaginary. They're just rational. So, or they're irrational solutions, which means I am not going to be able to find them without the quadratic formula. 4 and 3 would simplify that. Square root, square root. So I have negative 4 plus or minus 2 rad 3 over 2. So I have negative 2 plus or minus rad 3, all said and done. That's one solution. Another solution are the ones that I wrote. Make sure you always have the number of solutions as the highest degree. So I have 4, so I should have 4 answers. 1, 2, 3, and 4 because of the plus and the minus. So I know I'm good to go. Let's go ahead and do number 18. Again, I have to do P over Q. So I have negative 32 over 1. So I have, and that's just plus or minus 32. So that's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32. So let's go ahead and add these up to see if 1's factor. 1 and negative 1 make 0. 14 and negative 16 make negative 2. Negative 2 and negative 32. That's not going to make 0, so I know 1's not a 0. What about, let's try negative 1. Don't know until you try. 1, negative 1, 14, negative 16, negative 32. Bring down the 1. 1 times negative 1 is negative 1. Add them up, I get negative 2. Negative 1 times negative 2 is 2. Add them up, I get 16. Negative 1 times 16, I get negative 16, which add them up makes negative 32. Negative 1 times negative 32 is 32, which sure enough makes 0. Alright, so that's now x cubed, so that's still not going to help me factor, so let's try another one. Well, let's just try 2. I don't know if it's going to help me, but let's see. Bring down the 1. 1 times 2 is 2. That makes 0. 2 times 0 is 0. Add them up, I get 16. Oh, it's going to work. 2 times 16 is 32. Add 0. Done. So now I have x squared plus 16. So, equals 0. X squared equals negative 16. X equals plus or minus 4i. So x equals plus or minus 4i, 2 and negative 1. So let's go ahead and find P over Q. So P is 45 and Q is 2. So that's plus or minus 1 and plus or minus 2 on the bottom. 45 plus or minus 1 plus or minus 3 plus or minus 5 plus or minus 9 plus or minus 15 and plus or minus 45. So all my solutions plus or minus 1 plus or minus 1/2 plus or minus plus or minus 5 plus or minus 5/2 plus or minus 9 plus or minus 9/2 plus or minus 15 and plus or minus 15 over 2. Oh boy, so I got a lot of options here. So I know 1's not going to work. So let's try -1. 2, 2, -13, -13, -45, -45. 2, -2, 0, 0, -13, 13, 0. Now I have 0, -45, 45, and 0. Oh my gosh, that worked. Hooray! So now I'm down to x to the 4th. So okay, let's try another one. Oh, and over here I forgot 3. 3 and 3/2. So I don't really want to try fractions, so now let's try 3. Bring down the 2, I get 6, that makes 6. I get 18, that makes 5. I get 15, that makes 15. I get 45. Wow, I'm getting really lucky tonight. So that's 4th. That's now cubed. So I gotta try one more. Alright, well, let's just take a stab and try -3. 2, -6, 0, 0, 5, -15. Huzzah! So now I have 2x squared plus 5 equals 0. So I can easily solve this. I get -5. Now I have -5/2. Now I'm going to square root it. So x equals plus or minus I rad 5 over 2. Remember, I can't have that. X equals plus or minus I rad 5 over rad 2. Can't have radical in the denominator, so I gotta multiply the top and the bottom by rad 2. So x equals plus or minus I rad 10 over 2. That's one solution. Circle it in red so we can see it. Another solution is plus or minus 3 and -1. Let's make sure we have 5 answers. 1, 2, 3, 4, 5. Yep, great. Flip your paper. So let's go ahead and do the next one. Evaluate the following using synthetic division. So I'm going to put -1/2. Let me zoom in a little bit more. Okay. So -1/2. Now all my leading coefficients. Degree of 5, degree of 4 gets 0, degree of 3, degree of 2, degree of 1 gets 0, and then 6. And bring down 4. 4 times -1/2 is -2. -1/2 and -2 is 1. -3 times plus 1 is -2. That would make +1. I get 3. -1/2 of 3 is -3/2. Add that, I get -3/2. So what's -1/2 times -3/2? -1/2 times -3/2. That's going to be 3 over 4. So now I have to do 6 plus 3 over 4. So I got to find common denominators. So 4 multiplied by 4 multiplied by 4. 6 times 4 is 24. 24 plus 3 is 27 over 4. So by the remainder theorem, f of -1/2 is equal to 27 over 4. Given a polynomial function, determine if the binomial is a factor. So all I'm going to do is do synthetic division to determine if it is a factor. So 1, 0, -5, 14. Notice I'm finding the 0, which is why it's the opposite of the factor. So 1 times 7 is 7. 7 times 7 is 49. I get 40. I can't subtract. 44. 44 times 7 is 294, which added up is 308. No. X minus 7 is not a factor. Why? Because the remainder is not 0. Let's go ahead and try this one. Try 3. 2, -11, 12, 9. 3, 2, 1, nothing. All right, cool. Bring down the 2. 2 times 3 is 6. I get negative 5. 3 times negative 5 is negative 15. 12 and negative 15 make negative 3. 3 times negative 3 is negative 9. Negative 9 and 9 make 0. Sure enough, yes, x minus 3 is a factor. Let's go ahead and try the next one. Given the polynomial function n is 0, find all the zeros. So if I go ahead and I check out the next one, it says given a polynomial function n is 0, find all the zeros. Determine the end behavior, multiplicity, and sketch the graph. So okay, so 23 has a 0 of 5, so I'm going to write 5, and then degree of 3 is 1, coefficient of degree of 2 is negative 6, degree of 1 is negative 15, and degree of 0 is 100. Bring down the 1. 1 times 5 is 5. Add them, I get negative 1. 5 times negative 1 is negative 5. Add them, I get negative 20. 5 times negative 20 is negative 100. I'm left with 0. So now this has a degree of 2, so I can go ahead and write it out, and I can factor it. Factors of 20 that make negative 1, that'd be 4 and 5. 5 has to be negative, 4 has to be positive. So x equals negative 4, 5, and 5 again, because I had 5 up here and I had 5 down here, which means 5 has an even multiplicity. It has a multiplicity of 2. 4 has an odd multiplicity, which means it has a multiplicity of 1 because it repeated once. So my end behavior, so if I write that in a different color, as x goes to negative infinity, f of x goes to, so it's odd and the leading coefficient is positive, so it goes to negative infinity. And as x goes to positive infinity, f of x goes to infinity. Because this is odd, I always think about a positive slope line, and that's how I get my end behavior. So, okay, I've determined the end behavior, the multiplicity, and now I have to sketch the graph. So, plot negative 4, plot 5. So I start at negative infinity, so down here, and I come up to this 0. When I get here, since negative 4 has an odd multiplicity, I'm going to go through it, and then I got to have a turning point somewhere, so I'm going to go up and come back down to this 0. And at that 0, it has an even multiplicity, which means it's going to bounce back and come back up. So now if I go over to number 24, I'm going to do the exact same thing. So my first 0 is 3. So degree of 4's coefficient is 1, degree of 3's coefficient is negative 7, degree of 2's coefficient is 16, degree of 1's coefficient is negative 12, and degree of 0's coefficient, oh, actually, I messed up. How I know I messed up is because they all have an x in common. So I can first factor out an x. So now I'm left with x cubed minus 7x squared plus 16x minus 12. So now I can go ahead and do that. So x as a factor means 0 is definitely a factor, as a 0. So now I'm going to do synthetic division with leftovers. Degree of 3's coefficient is 1, degree of 2's coefficient is negative 7, degree of 1's coefficient is 16, and degree of 0's number is negative 12. So bring down the 1. 3 times 1 is 3. Negative 4 times 3 is add them up. Negative 7 plus 3 is negative 4. So now I'm going to do 3 times negative 4 is negative 12. Add it up, I get 4. 3 times 4 is 12. Add it up, I get 0. So now I'm left with x squared minus 4x plus 4. So now I can go ahead and factor this. Factors of 4 that make negative 4, negative 2, and negative 2. So x equals 0 is one solution, another solution is 2, and another solution is 3, because that's the one that I did up here. You don't want to forget that one. So 0 and 3 have an odd multiplicity. They both have multiplicities of 1. 2 has a multiplicity of 2. It has an even multiplicity. My end behavior, as x goes to negative infinity, f of x goes where? And as x goes to positive infinity, f of x goes where? So it's an even degree and a positive leading coefficient, so I always think about a parabola. So y's are both in the positive infinity range. So now if I go ahead and sketch my graph, 0 is going to be on one, 3 is going to be on another one, and 2 is going to be on another one. So I start out in the positive world, come down, come through because it's odd, turning point to this one. At 2, it's an even multiplicity, so it's going to bounce back, and then it's going to turn to go through that one. So let's keep going. Next one says, write the equation of a polynomial function in standard form that has the following zeros. So, okay, I see all my zeros. So it doesn't tell me what to use, so I can use f of x, g of x, p of x, whatever I want. So I'll just do f of x. Ooh, that turned weird. F of x equals, now I'm going to put all these in parentheses, so I take the opposite, x minus 4, x plus 1. And with this, when we have a fraction, remember the denominator goes up next to the variable. It's the opposite sign, and then it's 3. So I'm now going to go ahead and double distribute, FOIL out those two binomials. So I'm left with x squared, and then if I do the double rainbow, I get 1 and negative 4, which makes negative 3x, and then negative 4 and 1 make negative 4. And I'm going to multiply that by 5x plus 3. So x squared times 5x is 5x cubed. X squared times 3 is 3x squared. Negative 3x times 5x is negative 15x squared. Negative 3x times 3 is negative 9x. Negative 4 times 5 is negative 20x. Negative 4 times 3 is negative 12. So now I'm going to go ahead and add all of these up. F of x, I just picked that because it didn't tell me what to use, equals 5x cubed minus 12x squared minus 29x minus 12. And I'm done. That's interesting. That's not staying over there. All right, let's go ahead and let's look at number 26. With 26, I have an imaginary and an irrational root, which means they have their conjugate pairs. So I and square root of 3 are not the only zeros. Negative I is an option, and negative square root of 3 is also a root. So I'm going to call this one g of x equals x minus I, x plus I, and then I have x minus rad 3 and x plus rad 3. So I'm going to FOIL out those, and then I'm going to FOIL out those, and then I'm going to put them together. And the reason why I'm doing it that way is because I know their difference of squares, which means my middle terms are going to cancel out. So x times x is x squared plus ix minus ix minus I squared. I know I squared just makes negative 1, and those cross out, so I'm left with x squared plus 1. That's one option over on the left. So now if I come over and do this one, x times x is x squared. X times rad 3 is x rad 3. Negative rad 3 times x is negative x rad 3. Negative rad 3 times rad 3 is negative 3. These cancel out. I'm left with x squared minus 3. So now I just have to FOIL these two. So x squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. 1 times x squared is x squared. 1 times negative 3 is negative 3. And there's nothing else I can do, so I just got to give it a name. So we'll name it, how about g of x? If I come over and do the last one. Negative 1 is a 0, and then I have 2 plus 3i, so I know its conjugate is also a root. So I'll call this one h of x. I have x plus 1, and then I have x minus this, 2 plus 3i. That is always the opposite, so it's the my opposite, times x minus this. So now I'm going to go ahead and I'm going to distribute this negative inside. So I have x minus 2 minus 3i and x minus 2 plus 3i. So now I'm going to triple distribute all of this stuff. So x times x is x squared, negative 2x plus 3xi. Here, negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times 3i is negative 6i. So now I have negative 3xi, and then I have positive 6i, and then I have negative 9i squared. Whew! Alright, so now I can cross some stuff out. So I can cross 3xi out with negative 3xi, and negative 6i with positive 6i. I squared just makes negative 1, so that's going to be plus 9. So now I'm left with x squared minus 4x plus 13. That's 1. The other one is x plus 1. So now I'm going to distribute again. X cubed minus 4x squared plus 13x. And then I have x squared minus 4x plus 13. Now I'm going to add them up, and I'm going to call this h of x. X cubed minus 3x squared plus 9x plus 13. And it looks like, again, I have a typo on my answer key, unless I did it wrong here. Which I can see I did it wrong on my answer key, so it should be good to go on this one. So let's go ahead now and do this next one, number 28. So here calculator is allowed. So my degree, I would have x squared times x times x. So that's degree of 4. I should probably zoom this out a little bit more. All right. And that is a quartic. Max number of terms is 3 because n minus 1. So it's a degree of 4, but it has a negative leading coefficient because it's negative 1/2. So that means f of x is going to negative infinity on both. So now I want to know the x-intercepts. So the x-intercepts are 2, 4, and negative 1. And I'm just going to highlight the one with an even multiplicity. The y-intercept, so I just would have to plug in 0. Zero minus 2 is negative 2. Negative 2 squared is 4. 0 minus 4 is negative 4. 0 plus 1 is 1. So now I have negative 16, and I have to multiply negative 1/2 by that, which is 8. So my y-intercept is 0, 8. So I'm going to erase this so I have more room. So I'm going to go ahead and I'm going to plot each of these. So plot it at 2, plot it at 4, plot it at negative 1, and plot my y-intercept at 8. And I can go ahead and start graphing this, because I know it's going up here to down to 2, but then at 2 it's an even multiplicity, so it's going to bounce back up and come back down and go through. So for local maximum and local minimum and increasing, decreasing, the rest I'm going to do on my calculator. So I'm going to see if I can pull up the calculator here. Let's see if I know how to do what I'm doing. So I'm going to go ahead and I'm going to type this expression in. So I'm going to press y equals, and now I'm going to type it in, negative 0.5. You can do 1/2 if you'd like, parenthesis, x minus 2, parenthesis squared. If I can type with looking and everything else, squared, parenthesis, x minus 4, parenthesis, x plus 1. I'm now going to hit zoom 6. And I had an error somewhere, so let's go back and look at it. Oh, I have that fraction bar. Zoom 6. Watch for it to graph. Notice it looks very similar to mine. So now to do the increasing, so if I move this up here, to do the local maximum, I have 2 local maximums. So I'm going to do second trace, go to max number 1, and now I'm going to go to the left of that max and to the right of that max and hit enter. And my value is negative 0.147, so negative 0.15 comma 8.15. And my other maximum, gotta go to the left, hit enter, go to the right, hit enter, is 3.397, so I'm just going to say 3.4, comma, 2.587, so 2.59. So now I'm going to go ahead and do the minimum. So go to the left, hit enter, go to the right, hit enter. My minimum is 2, and then remember when I have that e to the negative, that just makes 0. So my minimum is 2, 0. So now if I go ahead and I keep going with increasing and decreasing, so it's increasing from negative infinity to right here, so negative infinity to right there, which is negative 0.18 bracket union, and it's also increasing from here to here, so that's 2 to 3.4. And it's decreasing from here to here, so negative 0.18 to negative 2 union, and then it's decreasing from here to here, so 3.4 to infinity. So concavity, it's concave up at x equals, up like a cup, it's at x equals 2, and it's concave down at x equals negative 0.18 and x equals 3.4. So if I go ahead and I do this next one, it has a degree of 4, it's quartic. Max number of terms is 3. As x goes to negative infinity, f of x is going to infinity. And as x is going to infinity, f of x is going to infinity. X-intercepts I have to find, so I'm going to go ahead and try to factor this. Factors of 48 that make 13. It is negative 16 and positive 3. So if I keep factoring, I have x minus 4 and I have x plus 4, and then I have x squared plus 3. So my x-intercepts are plus or minus 4. Both have multiplicities of 1. They're odd. I don't have to go ahead and solve this because that would be an imaginary solution. I can't graph that. My y-intercept is 0, negative 48. It's always the constant. Factored form is right there. So g of x equals x minus 4, x plus 4, x squared plus 3. So now I gotta go ahead and I gotta graph this. I'm gonna erase this so I have my room. So negative 4 and positive 4. And negative 48 is like somewhere way down there. So I'm starting at positive infinity, going down. It's going to have a max number of 3 terms, so you can kind of graph it and go 3 turns, and then it goes back up to here. If you don't like doing it that way, you can also try graphing it in your calculator. And when you graph it in your calculator and you zoom out, you're going to see almost the very similar thing. So if you do just sketch your graph and you just sketched your graph like a parabola, that's okay because that's what you're thinking. But I also got to keep in mind for my degrees of 3 as I go along the way. So my next piece is I have to go ahead and do my calculator. So I showed you how to do it on the calculator on the last problem, so I'm just going to go ahead and do it without projecting it. So x to the 4th minus 13x squared minus 48. So then I have to watch it graph, and I notice it's not well in my window. So I'm going to keep pressing zoom out until I see it. Or I can press my window and I can change my window. So I'm going to do, let's see. Still not good enough, but close. So now I see it. So now I have 1 maximum and 2 minimums. So my first minimum is negative 2.5 comma negative 90.25. My other minimum is 2.5 negative 90.25. And my maximum is at 0, negative 48. So it's increasing from here to here, which is negative 2.5, that has to have a staple. Negative 2.5 to 0. And it's also increasing from here to there, which is 2.5 to infinity. And it's decreasing from there to there, so negative infinity to negative 2.5. And it's also decreasing from here to here, which is 0 to 2.5. It is concave up at x equals plus or minus 2.5, and it's concave down at x equals 0. So if I go ahead and look at this next one, I know it's going to be y equals a times x, x, x. I have 3 zeros. So my 3 zeros, my first one is positive 1, so x equals 1, x equals negative 3, and x equals negative 6. So x minus 1, x plus 3, and x plus 6. So to find a, I'm going to take this ordered pair right there, which is 0, negative 3, and I'm going to plug it in for x and for y. So I'm going to plug in 0 for every x, and I'm going to plug in negative 3 for y, so negative 3, and then I'm going to find a. 0 minus 1, 0 plus 3, 0 plus 6. So now I have negative 1 times 3 times 6. So now I have negative 18. So now I'm going, oh, and I messed up because x minus 1 has a multiplicity of 2. So I have to make sure I square it. Square it. So it's positive 1 and positive 18. So now I'm going to go ahead and divide by 18. So a equals negative 1 over 6. So now I go ahead and I write this expression, y equals negative 1 over 6, x minus 1 squared, x plus 3, and x plus 6. I had to put this squared up here because I knew it bounced back, which meant it had an even multiplicity. So if I come over and I look at these ones, determine the end behavior. So if I go ahead and I look at these, that has a degree which is odd, and it has a negative leading coefficient, which means I'm going to think about it like a negative sloped line. So when x is negative infinity, y is positive infinity, and when x is positive infinity, y is negative infinity. If I look at the next one, it has an even degree, but a negative leading coefficient. So even makes it a parabola, but it's negative, which means it's going to look like that. So as x goes to negative infinity, y goes to negative infinity, and as x goes to infinity, y goes to negative infinity. If I look at the next one, it has an even degree, and it has a positive leading coefficient, which means it's going to look like a happy parabola. So when x goes to negative infinity, y is going to positive infinity, and when x is going to infinity, y is going to infinity. And last but not least, 34 has an odd leading coefficient. No, has an odd degree, but a positive leading coefficient, which means I'm going to think about a positive slope. So x goes to negative infinity, f of x goes to negative infinity, and when x goes to infinity, y goes to infinity. If I look at these next ones, it says use Descartes' rule of signs to determine the real, positive, negative, as well as the imaginary. So I'm going to come over here and write positive, negative, imaginary. So if I do the positives, looking at my first term, sign changes. Second to third stays the same. Third to fourth, it changes. Fourth to fifth, it changes, stays the same. So I have 3 positive potential real solutions. So now to do negative, I'm going to evaluate k of negative x. So I'm going to do negative x to the 7th minus 6 times negative x to the 5th minus 4 times negative x to the 3rd plus 2 times negative x squared minus 3, that should be an x, times negative x minus 1. So negative x to the 7th, that's going to be negative x to the 7th. Negative x to the 5th is going to be negative x, so negative times a negative would be positive 6x to the 5th. Negative x to the 3rd would be a negative, so I have negative and a negative 4, which make positive 4x cubed. And then I have positive 2x squared, because squared is positive. And then I have positive 3x, negative 1. So if I look at these ones, starting out my first term, my sign changes, but to my second to my third, it stays the same. Third to my fourth, it stays the same. Fourth to my fifth, it stays the same. And then from my second to last, it changes, which means I have 2 negative solutions. So now if I go ahead and I add this row up, 3 plus 2 is 5, but I need a total of 7, which means there's going to be 2 imaginary solutions. That's one possibility. Max number of positives is 3, max number of negatives is 2. But I could have 3 positives, 0 negatives, and 4 imaginary. Or I could have 1 positive, 2 negative, and 4 imaginary. Or I could have 1 positive, 0 negative, and 6 imaginary. So all I'm doing is I'm decreasing these by 2, and I'm increasing my imaginaries by 2. And why I'm doing it by 2s is because imaginary numbers always comes in groups of 2. So let's go ahead and let's do number 36. So I'm going to come over here and draw my chart. Positive, negative, imaginary. So if I look at my first one, first term to second term stays the same. Second term to third term, it changes. Third term to last term, it changes, which means I have a maximum of 2 positives. If I do negatives, p of negative x, negative x cubed is negative x, so negative x and a negative is going to make positive x cubed. Negative x squared is positive x, so positive times a negative is negative x squared. That's going to be negative 6x, and that's going to be negative 3. So now if I look at these ones, first term to second term it changes, second term to third term it stays the same, third term to last term it stays the same. So there's one possible negative. I can only have a total of 3 solutions, so 2 plus 1, so that would mean I'd have 0 imaginary solutions in the first possibility. So I can't subtract 1 by 2 because that's going to be 0. So you're going to always have at least one negative solution in each of your situations. But I can't subtract 2 from positive, and I could add 2 to my imaginary. And there's nothing else I can do, so those are all of my possibilities. These problems here require some of the calculator. So I'm going to go ahead and pull the calculator up again. Hopefully that has been working so we can see it. If not, I'm just making a fool out of myself. So if I come over here and I pull it up. So hopefully we can see where we left off on that one problem. So now I'm going to shrink this down so I can see it. It says, which data function best represents this data? So I got to type this data in. So I'm going to press stat, enter, and L1 I'm going to type in my x values. -3, -2, -1, 0, 1, 2, 3, 4, 5. And I'm going to type in my y values. 475, 363, 287, 233, 190, 148, 95, 19, and -90. So I'm going to try line of best fit first. So stat, go over to calc, number 4, scroll down to calculate. Notice r squared's not on, so I'm going to turn r squared on. So I'm going to press mode. Go down to stat diagnostics. Turn it on. So now stat, calc, 4. Oh, I typed 5. Let's go back to 4. R squared is 0.97, so that's pretty good. So now let's do quad. So stat, calc, 5. R squared is 0.978, so again, that's still pretty good. Let's try cubic. Stat, calc, 6. R squared is 0.99996, so that's pretty good. But let's just try quartic to make sure. Quartic is stat, calc, 7. .9997. So quartic is the best. So I'm going to go ahead and go stat calc, go down to quartic, and then I'm going to store in my equation. I'm going to do vars over to y vars, enter, enter, and then go down to calculate so it has that equation. So now I'm going to come over here and I'm going to write my expression. So it says what function best represented, and I'm going to say quartic, because r squared was the closest to 1. Write the polynomial function. So I got y equals 0.004371 x to the 4th plus, nope, it's minus 1.90385 x cubed plus 5.74446 x squared minus 46.21911 x plus 232.747, and I'm running out of room. All right. So now it wants you to estimate the value of y when x is 9. So if I open up another video here and I show you how I'm going to do that. So because I stored in y vars, I'm just going to do vars, hit vars, go over to y vars, enter, open up my parenthesis, and type. So prints on my home screen, open up my parenthesis, type in 9, because that's what I'm evaluating, and hit enter. I get negative 1077.15. So my y value is negative 1077.15. Number 38, I'm going to do the exact same way I did number 37. I'm going to type those values in. These are all my x values. These are all my y values. So I'm going to type those all in my values. I'm going to test all of them starting with linear. I noticed cubic is the best. It had the highest r squared. And then I would just write the equation down. So I'm going to go ahead and move forward. So let's look at number 39. 39 says, you are creating an open top box from a piece of cardboard measuring 12 by 16. So 12 by 16. You construct the box by cutting squares out of the corners and folding up the sides. So I'm going to cut up all these corners. What is the biggest cut you could make without cutting the cardboard in half? So the biggest thing that I could cut without cutting it in half, so if I were to cut this in half, it'd be 8, and if I were to cut that side in half, it'd be 6. So it can't be anything smaller than 6. So I always would say my domain would be somewhere between 0 and 6. So now it wants to know what the maximum volume of the box is. So because you only want this much of the sides, I don't know what these cuts are, so I'm going to label all of these X. I don't know, but obviously if I'm making a box, they all have to be the same. So I only want this piece. So this whole piece is 16, but I don't want these 2 X's. So this side is really 16 minus 2X. And this side here is really 12 minus 2x. So to find the volume, it's length times width times height. V equals, my length is 16 minus 2x. My width is 12 minus 2x. And my height is x. So now what I'm going to do is I'm going to type that into my calculator. So I'm going to type in 16 minus 2x, and then 12 minus 2x, and then x, and hit zoom 6. And I want to find the maximum volume. So since V stands for y, on my graph, I'm going to find the highest point. So I'm going to find its maximum. And I'll go ahead and pull it up to show you. So here's the maximum, and notice it looks like over here I'm going to have another maximum, but my range is only between 0 and 6. Otherwise it's not going to be, it's going to be cut in half, which means it's not going to work. So this is my maximum right there. So I want to find the y value of this spot here. So I would just do second trace maximum, go to the left, go to the right. It's 194.06. So my highest maximum is, my maximum volume is 194.1 inches cubed. So now it says, what are the dimensions of the box that has the maximum value? So the dimensions, that's x. So my x was 2.26. So I'm just going to say x, which stands for the height, because if you think about it, you'll be folding it along that side. My height is 2.3. which means my length, when I plug it in, so I would do 16 minus 2.3 times 2. I get 16 minus 2 times 2.3, if I can type it in correctly. I get 11.4, so if I round to the biggest one, it would be 12, round to the nearest side, or it would be 11.4. And my width, I would do 12 minus 2 times 2.3, and I would get 7.4. You don't really want to round, so let's take that back. So it'll be 11.4 and 7.4. So now if I look at number D, letter D says, if the cuts are made by 1.2 inches, what will the volume of the box be? So now it's saying X is 1.2. So I'm just going to take my volume formula, 16 minus 2 times 1.2, and 12 minus 2 times 1.2, and 1.2, and I'm going to type all of that in my calculator. 16 minus 2 times 1.2, 16 minus, if I can type, 12 minus 2 times 1.2 times 1.2. And you get 156.7 inches cubed. If I look at the next one, it says the volume of a cedar chest whose length is 3 times its width and whose height is 1 foot greater than its width is 36 cubic feet. So, all right, I gotta draw a picture. So I'm gonna draw a rectangular prism. So it says its length is 3 times its width and its height is 1 foot greater than its width. So I know the width is x because I know nothing about the width. So the length is 3 times its width, so that's 3x. And its height is 1 foot greater than its width, so x plus 1. So now I'm going to define the volume. I just do 3x times x plus 1. So I have 3x squared times x plus 1. And 3x cubed plus 3x squared is my volume. And my volume has to be 36 cubic feet. So now all I'm going to do is I'm going to make this equal 0. So 3x cubed plus 3x squared minus 36 equals 0. So now I'm going to type that into my calculator in my graphing portion. 3x cubed plus 3x squared minus 36, zoom 6. And I'm going to find all of my zeros. So it looks like I have a 0 at 2, which means x equals 2. So since x is my width is 2, which means my length is 6, and my height is 4. If I look at these last problems, I'm just going to go ahead and solve these polynomial inequalities. So I have to factor. So I'm going to take out an x. I'm left with x squared minus 16. I now have x plus 4 and x minus 4. So all of my solutions on my number line are -4, 0, and 4. So now I have to test values. I want to pick a value to the left of -4, so let's pick -5. If I plug -5 in there, it'll be negative. If I plug -5 in here, it'll be negative. If I plug -5 in there, it'll be negative, which makes negative times a negative times a negative is a negative. If I pick a number between -4 and 0, let's pick -1. If I plug -1 in here, it will be negative. If I plug -1 in there, it will be positive. If I plug a -1 there, it will be negative. Negative times a negative is a positive. If I pick a number between 0 and 4, I'm going to pick, let's say, 2. If I plug in 2 here, it's going to be positive. If I plug in 2 here, it's going to be positive. If I plug in 2 here, it's going to be negative. So it will be negative. And if I pick a number greater than 4, I'd say 5, and I plug it in there, it will be positive. If I plug in 4 here, it will be positive. And if I plug in 4 there, it will be positive, which means they're all positive. I now look at my inequality symbol. My inequality symbol is greater than, so at all of my zeros I have open dots, and wherever there's a positive is where my solution is. So my interval notation is -4 to 0, union with 4 to infinity. If I come over here and I do number 42, I have to factor by grouping, so I'm going to take out an x. I'm left with x squared minus 4. And on the other side, I'm going to take out a -5. I'm left with x squared minus 4. So x minus 5 and x squared minus 4. This is a difference of squares. I can go ahead and factor it. X plus 2, x minus 2. And then I have x minus 5. So now I have -2, 2, and 5. Now I'm going to test values. If I pick a value that's less than -2, let's pick -3, and I plug it in there, it will be negative. If I plug in -3 there, it will be negative. If I plug in -3 on my last term, it will be negative. Negative times a negative times a negative is a negative. If I plug in -2, any number between -2 and 2, let's say 0, if I plug in 0 here, I get a negative. If I plug in 0 there, I get a positive. And if I plug in negative there, if I plug in 0 there, I get a negative. Negative times a positive times a negative is a positive. If I plug in a number between 2 and 5, let's say 3, and I plug in 3 there, I get a negative. If I plug in 3 there, I get a positive. If I plug in 3 there, I get a positive, which will make negative. And if I pick a number greater than 5, let's say 6, and I plug in 6 here, that will be positive. And if I plug in 6 there, that will be positive. And if I plug in 6 there, that will be positive. Positive times a positive times a positive is a positive. I'm now going to look at my inequality symbol. It's less than or equal to, which means all of these will be closed dots. And everywhere there is a negative is my answer. So my interval notation is -∞ to -2, union 2, 2, 5.